I am pleased to introduce Marlon Chung. He is a cloud security architect at Checkpoint Software. He is a specialist in DevOps, DevSecOps, and emerging technologies for enterprises. For the enterprise, with over 25 years of progressive experience in information technology with a solid background in cybersecurity. With his wealth of experience in architecting and designing solutions using cloud, Azure, AWS, and GCP, in this session he is going to share the challenges with DevOps services and DevSecOps strategy as the enterprise adopts to the modern cloud.
All right. Thank you so much.
You bet.
All right. That's it. Welcome, everybody. Quick survey. How many here are local or flew drove in for this event? Hands up. Out of town? Did you come from somewhere warm? No? Cold? Hey, you know what? I came from Southern California. And trust me, I should have been a bit more prepared in my dressing, right? But you know what? I thank you guys for providing that hoodie because now I can wear that the next 3 or 4 days while I'm here. But you know, it's a quick reminder that wherever you go, you got to be prepared in the weather conditions and so forth. I do have my Kubernetes jacket on, right? I'm not going to wear it because it gets hot up here. But I'm glad to be here. This is my second time in Chattanooga. My first time was in the summer when I did the Scenic Summit event. Some of you may have been part of that presentation I gave. If you did, well, here's your second viewing of my presentation. Nothing has changed since then. But I'm glad to be here on stage to share with you what we're doing in the DevSecOps world as Checkpoint sees it, right? As the gentleman said, I've got experience in the wealth of cybersecurity. I'm not a developer. I'm not operations. I'm DevSecOps. They sandwich me right in the middle. Why? Because we understand the challenges of developers. We understand the challenges of the operators. So hence, DevSecOps. We understand both fields. And that's why I'm here today to share with you what we're doing today in the industry. Now, everyone here knows everybody? Kinda? Reach behind you. Say hello to your neighbor, right? Network. Good. Share your first name, last name, whatever you want, your Twitter account, your LinkedIn, right? Now we're all networked. I don't know any of you guys, but you know what? I'm on LinkedIn. Marlon Chung, and you can find me there. Now, today's presentation is all about your code to the cloud and the security that should be at forefront at everything you do today when you do your code to the cloud. But I want to share with you my foot to the cloud. And what does that mean? Well, it means I was a former soldier in the military for 13 years in the Canadian Special Forces. Yeah, I jumped out of airplanes and everything. But my journey started at a very young tenure when I was in the armed forces. So can you imagine, as a young soldier, just getting out of boot camp and he's stationed at his first post. And all of a sudden, hey, you're on the battlegrounds and you're doing your exercises, and you see these soldiers jumping out of not so perfectly built aircraft. There's always something wrong with those aircraft. I trust you. Okay? How many here are military, ex-military, active, veteran serving? All right, a few there. How many of you jumped out of an airplane before? Skydive, civilian, or in the military? Okay, great. So you know the preparation that goes into you jumping out of a not so perfectly built aircraft. Right? So my journey took me from foot to cloud. I wanted to be one of those guys jumping out of that airplane. I wanted to be an elite soldier. Now, there's a lot of work required into getting to that level. Because it takes a different breed of person to put on a parachute and go jumping out of an airplane at 10,000 feet with equipment on. There's a lot of preparation. You're trusting your fellow members to check your flap on your parachute to make sure the pin is in the right position. Agree? You're trusting the load masters on the aircraft to load you correctly and get you from point A to point B. You're trusting the pilots to drop you off in the right coordinates, especially at nighttime. right? When you get to the ground, you still have to maintain security of the drop zone because you're securing that for the main body that comes in afterwards. So my point is, at every point of our deployment, from the time you put on your parachute, from the time you load yourself on the aircraft, the time you jump out, secure that drop zone, security was at the forefront of our minds all the time. Okay? Security. Now, take that same analogy and apply it to the everyday work that you do today when you build your code from monolithic applications to serverless or adopting a modern cloud today. It's the same principle, same framework. Keep security at the forefront of everything you do. And I use the military as an example. Now I'm going to share with you a quick video, a 47-second clip video, that kind of wraps up my journey from foot to cloud. Okay? That was my foot to cloud, the journey I took, and the security they adopted along the way. What did you notice about that video? I'm going to randomly pick on somebody here. This gentleman here with the green jacket on. What did you notice about that video, sir? Pardon me? Young guys? Sure, I'll buy that. What's that? Yeah, sweet mustaches. What about this gentleman right here, sitting in front of me? Good time, right? Anyone else? Over here on the very left. Anybody? What did you know about that video? Those guys? Anybody? I like that. I like that. Relaxed. Having fun, right? And of course, the cosmetic, the mustaches, and everything else. The main point here is that everybody in that video were having a good time. Most importantly, they were passionate about their work, their craft, and relaxed and having fun. So as you move from code to cloud, these are some of the things I want you to adopt. Have fun at what you're doing. Have passion, right? But at the same time, have full awareness and security along your software development lifecycle. And I'll talk about the SDLC. Right. So enough about my foot to cloud. Let's talk about your code to cloud. And these are some of the challenges that we see in the landscape today. And I want to kind of pinpoint a few of them. Now, you may have different challenges, right, that you're experiencing today, but these are the common ones that we see going forward, or what we're seeing as people are adopting the modern cloud. Silo, right? Silo. When you have highly skilled engineers looking at the same code, what do you think that's going to present? If you have no collaborative sort of platform to look at the code from a single point of view, you're going to create bottlenecks. Correct? Correct? Oops. Did I lose that? Okay. Bottleneck. But also, we're all humans. We're going to make mistakes. So the human error effect, right? Human error and bottleneck. We need to break down that silo, and you need to introduce a platform of tools that makes sense to you and your current workflow in your particular use case. Agree? All right. Second one, supply chain. If you're developing applications in a native cloud, right, but you're also adopting third-party binaries and libraries because they're readily available off the shelf, what you're going to have is supply chain within supply chain. Hence the SolarWinds type of issue that you heard about last year, right? Supply chain attack. You can have supply chain within supply chain. Well, if you're developers and you have no way of separating your native code from all these third-party binaries, guess what's going to happen? Those third-party binaries are going to piggyback along the same permissions as your native code and access your back-end applications. Hence, you have malicious content within your framework, within your supply chain, right? So supply chain. Observability data. I break this down into two parts. Number one is that as developers, you are concerned about developing your code in a very high-speed environment, right? And you're worried about performance, optimization. But as security analysts, we are kind of looking at the breadcrumbs, looking at the security, the malware or the malicious content within that code. Right? How do you provide tools that make sense to your use case to look at that code? And we'll talk about that as well. Legacy technology. If you're running legacy technologies, I like to pick on legacy web application firewalls, because most of them are still running out there based on binary decisions, right? So binary decisions mean that incoming traffic looks at your web application firewall based on built-in dictionary of known attacks, is going to either allow it or disallow it. How can you keep up with that sort of legacy technology? You're going to introduce a lot of false positives, not to mention updates that are not going to be frequent. Most importantly, developers are developing these applications at a high speed and cannot afford to have a security solution that's going to slow them down. So you need to have an automated solution within your, in this example, a web application firewall technology to keep up with the developers as they're adopting the modern cloud. And data integrity, making sure that you know where your data lives, it's secure, right? And the code is accurate, because let's face it, you're dealing with millions and millions of lines of code. And you're subject to inject, not on purpose, but secrets in your code that could be exposed in your GitHub, for example, right? So point here is everything needs to be automated. Everything in the cloud today is all driven by APIs, okay? So everything needs to be automated when it comes to that. The 4C model, quickly. You're only as strong as your weakest link. So an example, as you're deploying your, for example, a cluster, right? You're going to have to have security within your cluster, because the basic tools that come with the cluster are not going to be good enough. So you may need some containerized security within your cluster, workload protection, right? Infrastructure, your cloud provider. If they're not providing any sort of enhanced securities within your deployment, within your infrastructure of your choice, then that becomes a weak link. And obviously your code, looking at your code, static code, making sure that it doesn't have any malicious content in it. So you're only as strong as your weakest link when it comes to the 4C model, and that's based on defense in depth. At Checkpoint, this is what we're observing as customers are adopting modern cloud. And let's face it, as you move from monolithic to microservices, you're going to open up the security risk and also increase the attack surface. Why? Because everything in the cloud is driven by APIs, right? This is going to expose APIs, your tokens, your secrets. So as we look at the infrastructure model, your cloud provider is going to give you access into the infrastructure of your choice. Mind you, they're probably more focused on the optimization of your access, but you, as customers, need to provide extended security solutions to protect your crown jewels and your workloads. So that becomes the shared security model, or shared responsibility model, right? And you look at vendors such as us to kind of give you that advanced security to protect your crown jewels and your workload. Now, you may have applications out there that need protection. How about your APIs? How about bot management? Deciding what's a human versus machine. Now, as you move into the cloud, this is going to present or create a very complex architecture. Because you may have environment, living on-prem or in the cloud. A hybrid environment, right? You may have workloads in different cloud providers, GCP, AWS, and Azure, and so forth, right? So it becomes a very complex architecture. And that's why all these APIs out there need to be protected. You may have workloads in Kubernetes, microservices, or virtual machines, or serverless environment, such as AWS or Azure. How are you protecting your serverless functions as you deploy your serverless apps? These are things you need to think about. And of course, as we roll up into the different automated platforms that make sense to your use case and what works for you, how do we integrate all these different solutions in your pipeline of your choice? Okay? So, in the end, you may have all these different point solutions that are providing access and security for all the different architectures within your environment, and that's fine. But what about introducing a platform that can have visibility into all those complex architectures from a single platform for auditing, for troubleshooting, for network traffic and intelligence, for policy enforcement? Right? This is where the Checkpoint CloudGuard product comes into play. Okay. Now, part of our solution is looking at our threat cloud. The threat cloud is our granddaddy of all. Not all security vendors out there have their own threat cloud environment, per se. We have our own threat cloud environment. We manage our own threat cloud environment. That's why we're able to stay or have a solution for Log4j that came out last year, December. Everything we do within the threat cloud is based on preemptive AI machine learning engines. We control our own CVEs. That's why we're able to have a solution for Log4j before publication. Right? Not to mention, we look at millions and millions of IOCs, indicators of compromise and indicators of attacks. IOCs looking at breadcrumbs, right? IOCs looking at the attack in real time. So attacks here in North America can be prevented in Australia in less than 2 seconds. The fastest catch rate. So our threat cloud is based on over 40 plus AI and machine learning innovative techniques. And this is what drives all our products within the Checkpoint family, our handheld security, our gateways, to get automatic updates from threat cloud without any human intervention. This is huge, right? Our threat cloud. I mentioned CloudGuard, a game changer. So within our SaaS-based portal, within that solution, you'll find CloudGuard. And this is a product that will give you visibility across all your complex architectures for policy enforcement, for visibility, for network traffic analysis, intelligence, reporting, and so forth, across all the different cloud vendors and even on-prem. Again, driven by Threat Cloud. Now, within our cloud native solution, we have a product called Shift Left. And I'll talk about Shift Left more in depth. So with Shift Left, you're looking at introducing security in the early inceptions of your software development lifecycle. Right? Meaning that as developers are developing your code, and I've spoken to a lot of developers, and it's not a bad thing, but you know, mostly the ones I speak with, security is not really in their kind of orbit when it comes to developing their code, right? And that's based on my experience from the ones I speak to, right? You're more inclined to develop your app as fast as you can, optimize it, get that into modern cloud. So security is not really part of your focus when it comes to the introducing security in the early inceptions of your pipeline. So with Shift Left, You're introducing security in the early inceptions of your pipeline, but most importantly, you can also integrate this with your common CI platform tools today as a Docker image, right? When you download a Docker image, the binary CLI commands will be built in that image, and you can carry out a scan on your environment, right? We look at 3 different things. Image assurance, so image scanning, looking at CVEs, looking at known vulnerabilities, looking at malicious URLs, IPs, credential leakage, and so forth as part of the image assurance blade within shift left. But also code scan, right? Static code scan of your code build, and also ISC scan. So infrastructure as code templates, whether it's CloudFormation templates, AWS templates, Terraform templates, right? We can scan it all. We have a broad support from different ISCs. So that's the shift left. You can run as a standalone, but also a part of your CI platform as a Docker image. Spectral. We purchased a company back in January of this year to look at secrets that were exposed in the most common place, your GitHub, right? So secrets was a cornerstone, or you can say it's a cornerstone for connectivity between your applications and your infrastructure. And as I said, the biggest culprit out there was GitHub. Anybody here? I'm pretty sure everybody here uses GitHub, private or public, right? So the ability to expose secrets in your repository was something that was missing as part of the overall security exposure within Checkpoint. So we purchased Spectral. Not only secrets, but also ISCs as well, and SCA, Software Composite Analysis, and SAST, right? So all these different features are all part of the Spectral product today. There's about over 1,400 different types of secrets that we can scan for in your repository, right? So again, this is Spectral that we purchased earlier this year for that main use case. And obviously, with the Spectral, you can also integrate that with your common CI platforms as well. Our next generation web application firewall is built on AI and machine learning contextual analysis, not binary. So it's based on layer 7 HTTP incoming requests into your web application. Can be deployed in AWS and Azure, or on-prem in your VMware environment, or part of a ingress controller in your Kubernetes cluster, right? So we're looking at incoming layer 7 HTTP requests, not binary decisions. And everything we do here is based on AI and machine learning contextual. And back to my point, Log4j. We're the only ones back in December last year to have a solution for Log4j because we control our own CVEs within our own threat cloud. Okay? I can share a blog with you afterwards, how we did it. We also do API protection in a positive and a security type of model. So positive, meaning that you can upload a schema validation file into the product to look at who can access your API infrastructure. Or as a negative security model, looking at malicious content in your APIs. Both can be deployed at the same time, negative and a positive in terms of the API protection. And bot prevention using JavaScript, deciding what's human versus machine. So we inject a JavaScript in the user session, and based on that, we collect behavioral type of analysis to decide whether it's a machine or a human. Last but not least, workload protection, right? Container security, self-contained security. As you deploy your workloads into a cluster. There are 3 different types of blades that we're assessing within this family when it comes to container security. One is image assurance. The same image assurance that I spoke about within the shift left. So we're leveraging the same engine. Okay? Also, runtime protection. Looking at intercepting system calls. and doing behavior analysis and looking at signatures that are built in within the product itself to compare against to see if there's any malicious content, right? So that's runtime protection. And also code scan as well, right? Oh, I'm sorry, not code scan, but emission control. Emission control looking at intercepting system requests into API cluster environment. So think of it as a webhook request that intercept those calls requesting access into your Kubernetes API server. And the last fun part is serverless functions. How are we protecting your serverless functions? Well, as you build your serverless applications, they're going to build up, they're going to create functions. So we can apply a workload protection like a gateway on that function itself as another layer. Protect your S3 buckets and so forth, right? So that's part of the workload solution for protecting serverless functions within Azure and AWS. Any questions? Now, I kind of wanted to go in deeper about what Spectral is, because it's relatively new. And Spectral, like I said, was a product we purchased early this year, right, in Israel, and looks at secret scanning. So number one, some of the key attributes is that when you're scanning, for example, an environment like GitHub or Bitbucket, right, we're not taking any proprietary information from that environment. We're taking the metadata, and you log onto the dashboard, and all we're telling you is where the issues are within your GitHub. So you can go take a look at it, look at the playbook that gives you more information about that issue and how to remediate it, fix it. So data privacy. We're scanning in less than 7 seconds because we use Rust as a language in memory, so super fast scanning. Language agnostic. Because we're scanning for a text, it doesn't matter what the language is. So we're language agnostic in terms of the scanning. And using our AI detectors for low false positive to cut out a lot of that noise. And as you see in the bold here, this was a product developed by developers for developers. And can be integrated in your common CI platforms today. Or you can run it as a standalone. It's a binary. And all our secret sauce, all of our 2,000 plus detectors is in the binary. So when you run that scan locally on your platform of choice, whether it's Windows, Mac, or Linux, or BSD, you will see the findings based on your CLI scan, right? So this is Spectral, and this is what Spectral is about. Here's a dashboard of Spectral. You will see that you have a card, and all this card, within this card, you have a bunch of Rubik's Cubes. Those Rubik's Cubes represent the repos that you've scanned. And you can customize your team dashboard to who has access to it. You can create more team dashboards for different groups within your organization and give them access to it, right? Here's a scan of a finding. You click on the link, and it tells you where it is in your GitHub, and the playbook will give you more information about how to fix that issue. Okay, so Spectral dashboard. Come by afterwards, talk to one of us. We can do a short demo, right? Or another time when it's convenient, we can give you another demo and presentation on Spectral. So, from code to cloud to glory. Question here. These 3 bullet points. Which one of these do you think you fit into? I'm going to randomly pick somebody out here in the crowd. That fellow right here with the glasses shaking his leg. You fit in the first one? All right. Next person here, the gentleman with the glasses. Where do you think you fall into? The third one? Here. You get checkpoint socks. All right, anyone else? Yeah, you? Third one? Sure. Boy, I tell you, it's contagious, isn't it? Oh, yeah. It's contagious, isn't it? Here I go. All right. How much time do I have left? 1 minute? All right. So I got 2 socks left. 2 checkpoint socks. Aren't they good? Yeah. So, in terms of security and SDLC, where should security live when it comes to your SDLC? That's your software development lifecycle. I'm looking for an accurate answer before I give this sock up. I'm going to choose that gentleman right there, the glasses. Nope, right here. The one beside you. Oh, you? Okay, sure, you. Yeah. Where do you think security? Where do you position security in your SDLC? Everywhere? Where do we start? Right, development, right? Shift left, right? At the early sections of your pipeline. There you go. There you go. And last one. Our web application firewall is based on binary decisions. I'm going to pick somebody from right there, the gentleman at the far seat. Am I right or wrong? Our web application firewall is based on binary decisions? Or it is? Oh, what is ours based on? Somebody help him out. Contextual, AI, machine learning. There you go. That gentleman gets a sock. I'm sorry, guy. Anyways, my last 3 bullet points. Be aware, right? Have a mindful thought process of dependencies, right, and third-party dependencies and so forth. Have a consistent formula that makes sense to your use case. No sense having these beautiful tools out there if it doesn't fit into your use case and your use flow and make sense to your people in your department, right? And that concludes my Code to Cloud presentation today. Hope you had fun, and we'll see you soon. Maybe in AWS reInvent, where I'll be replicating this same presentation at AWS. So that's it for me.
All right. Thanks, Marlon.
Okay.